Hi guys, in this video we're going to talk about what makes materials magnetic. I have some handy Cornell paper here that I'm going to write on, but I've also got some little things that I'm going to use to show you what we're doing. So to begin with, we're talking about magnetic materials here. And our essential question is, what makes something magnetic? And what we want to do first is kind of distinguish between the difference between something that is a magnet and something that is responds to a magnet. So when we talk about permanent magnets, these are things that are always a magnet. They attract other materials. They are the magnet themselves. And then we have these things called ferromagnetic materials, and these can be attracted by a magnet. Some of the other metals, cobalt, iron, those things are ferromagnetic, ferro meaning iron-like. They can be attracted to by a magnet or to a magnet, but they themselves are not a magnet, but they can be made to be a magnet. Some of them can be made to be a magnet, but they're not a permanent magnet, and we'll talk about that too. Okay, so to begin with, we have to zoom in as far as you can to the individual atoms. And each individual atom has a set of electrons. And those electrons, they have this property called spin, and it's kind of like the electron is actually spinning. And this spinning electron does something very special. It has some magnetic properties of its own. And so if we look in an atom and we pretend that these are the electrons, in any old atom the electrons might be spinning in a whole bunch of different directions, and this atom has its electrons all over the place, but some atoms have their electrons more or less spinning in the same way. So in that case the arrows might all point in the same direction, or mostly the same direction. And when that happens in an atom, the atom kind of acts like a tiny magnet. And if a bunch of atoms, this is one atom. If a bunch of atoms happen to be this way, that's called a magnetic domain. So those little electrons in one atom add up to make a bigger domain in a set of atoms. And in a material, if a bunch of the domains all point in the same direction, then it is a permanent magnet. In a material that's not a permanent magnet, these might be able to turn and face a bunch of different directions, or maybe only some of them point in the same direction, but if they point in a bunch of different directions, then it kind of cancels out and it's not a magnet. But you can make this in a ferromagnetic material. These domains can turn. In plastics and things that are never attracted to a magnet, those things don't turn. But if you bring it up to a piece of steel or iron, a magnet will stick to it because it makes those little guys turn just enough to be able to respond. Now I have a magnet here, and generally speaking I think the arrows usually point toward the north end of the magnet. There's my magnet. Can you see the north and south end? So I can take a non-magnetic material and I can turn it into a magnet by repeatedly stroking the north end, and that's just going to pull all those arrows gradually to turn around as I do that, and then eventually they'll all be pointed the same way. That's how you can make a magnet. You're going to do that in a lab. Although you may have already done that, I don't remember. But you can make something into a magnet by stroking it with the same pole of a magnet. If I stroke it with the south end of the magnet, then I would turn everything around the other way. But so it depends on which end of the magnet that I use. But the thing about when you make a ferromagnetic material into a magnet, as soon as you drop it, they all get mixed up and then it's not a magnet anymore. So they're kind of, what's the word, not stuck that way like in a permanent magnet. In a permanent magnet, those domains are stuck facing the same direction. In a ferromagnetic material, they they can be made to point in the same direction, but they don't have to be. So the atom's electrons, they have a spin, and sometimes the spin lines up. Sometimes the spin lines up. If we zoom out just a tiny bit, zoom out a bit to a domain, which is just a set of atoms. Sometimes the domains align, and sometimes they don't. Some materials have a little bit more of domains than others, but it just depends. So if the domains align and they're stuck that way, then you end up with a permanent magnet. Permanent magnet, and if they can be moved, then you have a ferromagnetic material, permanent magnet. And then if they can move to be aligned, then you have that ferromagnetic material. So ferromagnetic material is not a magnet itself, but it can be made into a magnet. And those guys are the ones that do the reacting. So to make it into a magnet, stroke it. You take a needle and you can, eventually it'll be a magnet with the end being the same end or the opposite end that you're doing this. If you stroke it to align them, but you drop it or heat it to return to normal. So magnets are actually pretty interesting. So not all materials can be a magnet, only some of them can. So if you have any questions about that, make sure you ask your teacher. Thanks for watching.